In this video, I would like to introduce you to how we, as a class, are going to understand two particular very important words. So those two words are dimensions and units. And so we'll talk about dimensions and units in this video. So the point is, science is a very careful effort by people to observe and try to understand nature. So the reason I understand very careful is that's part of the reason why I want us to be very careful about what kinds of things you can measure in nature, right? Another reason that I understand very careful, underline very careful, is different people from different countries need to be able to talk to each other about their ideas and observations and outcomes of experiments, right? So essentially, science needs to have an agreed upon way of talking about physical quantities and phenomena. That is, science needs to have a consistent, careful language, right? So we need consistent definitions for the various physical concepts like energy or momentum or mass, electric charge, lots of different concepts, right? And the idea is we want to be able to preserve observations in the sense of recording them and understanding later what those prior observations actually meant. Answers to questions and communicating just raw data. So let's talk about dimensions and units. Dimensions, these are the idea of the measurement. And what I mean by idea is it's very generic. I think the best way to describe dimensions to somebody learning in introductory science class is to actually just give you some examples. So the first example of a dimension of measurement or a dimension for physical data is just the dimension of length or distance, right? So this is a particular dimension or thing to measure. It's an idea to measure. Another one is time duration. It often doesn't matter in science what time it is. It doesn't matter if it's 2 p.m. or 5:15 p.m. or midnight, right? That issue doesn't really matter in science. What does tend to matter in science, especially physics, are time durations of a second or a millisecond or a full year for the Earth to go all the way around the sun and get back to where it started from, right? Time durations tend to be a physical dimension that is meaningful in the science. And then the last one, the third one, at least that we're going to start off with in our physics class, is called mass. Another way to understand this kind of dimension is really interesting. It's the amount of material, right? Notice that the word weight is not the same thing. Actually, so weight is not an example of mass. Weight and mass are different issues. But weight itself is you could maybe say it's a fourth dimension to measure, although we're going to be more careful than that in the future. Anyhow, these are the basic sort of dimensions that we can do a lot of physics, a lot of physical science thinking with these three basic dimensions. So that's the idea of dimensions. But the other word that's really important is units. And units and dimensions, as far as this class is concerned, as far as how we're using the language, I really want to separate the two concepts, the concept of the unit and the concept of the physical dimension of measurement. So here is some units. So units, what they are standards against which a scientist can make measurements. So it's interesting. Like, let's go back to the dimensions. Let's say that I wanted to talk about a certain distance. You don't need any units to maybe describe that one distance is bigger than another. And in a sense, you don't really need units to be able to say that one distance is twice as long as another, or 10 times as far, right? But if you're trying to communicate to somebody, say, in the future, some piece of data associated with distance, then instead of that future person having to actually look at the phenomenon themselves, like look at the building or the tree or the coastline, right? They don't need to actually look at the thing if there is some way to communicate what was observed. And that's what the units are for. They are standards. So a future person understands the unit the same way that the person in the past did. And a person in China working on science can understand the very same unit, the standard unit, that somebody from Brazil may have used, right, to describe a particular measurement. So just like I gave you examples, basic examples of dimensions, let me give you some basic examples of units. So to measure length, we could use the unit of what's called the meter. And the meter is often abbreviated with just a lowercase m. So that is a standard length, right? It's a particular length. And scientists in Brazil and scientists in China, they know what that meter is. And actually, if you took a Brazilian meter stick, put it next to a Chinese meter stick, they will show you very much the same length because it's a standard. Another standard unit is a unit to make descriptions of time, measurements of time. And the standard unit that we'll use in our class is called the second, S. So it's absolutely true that the year is another unit of time duration, and the month is as well, although it depends on what month you're talking about, right? Because February is a couple of days shorter than January, right? But the second, it sort of doesn't matter what month it is. The second doesn't matter about anything. The second is a standard. And it's also a useful standard. It's an amount of time that sort of makes sense to pay attention to because a lot can happen during a second, right? This could be the entire time duration of an automobile accident, for example. It takes a full second for the collision to finish. So the third unit that you're going to learn how to use in this class is associated with amount of material, the mass. And that basic unit is called the kilogram. And this is abbreviated as kg. And secretly, this is a kilogram. So a gram is a really small amount of material. A kilogram is 1,000 grams worth of material. But kilograms tends to make sense for how we think about stuff that you see every day. It's true that maybe an automobile is 1,000 kilograms itself. A person is about 70 kilograms. But a bottle of water, it could be a kilogram or two, right? So these are things that we can hold in our hands comfortably. So these are the standard units. And in fact, they're so standard that the standard is maintained by an international body, right? So lots of governments are associated with this, lots of universities all over the world, and they maintain what's called the international standard. And the meter, the second, and the kilogram are international standards that this international body maintains. This international body is referred to as the SI, the System International. So I get you to try to read about the System International, right? If you go and you look, you're going to see many, many, many more units, because actually these basic units, they get you pretty far in doing a lot of physics. But for example, as soon as you start to try to understand something like electricity and magnetism, you can't do any work in electricity and magnetism unless you start to think about a dimension of measurement called electric charge. And as soon as you have a new dimension of measurement, you need a new standard of measurement, and that standard is called the Coulomb. So the Coulomb will come up much later in our class, but it is an SI unit that is a particular amount of electric charge. Yeah, so that's pretty cool, right? When new physics shows up, you have to have some new dimensions, possibly, and some new units. And if you discover a new dimension or a new unit, or in particular a new dimension, I think people in the future who look back on your work, your important scientific contributions, tend to name unit names after those important scientists. So here's an example. This person, Coulomb, is a person who did a lot of important work in the foundations of thinking about electrostatic charge. Okay, so before I finish this little lecture for you, I want to also point out that you can do math with units and dimensions. That is, you can do math. You can multiply, divide, add, and subtract. So add and subtract, these are things you can do, right? They are mathematical things you can do. And it makes sense to, for example, take a length and add it to another length. It makes sense because these are both in the dimension of length. It also makes sense to take some time and add it to some more time, or even subtract, right? It also makes sense to take a 2 kilogram object and put it together, or tape it to, or glue it to a 1 kilogram object. And we can definitely imagine this as being 3 kilograms of material, right? So dimensions and units, you can add them and subtract them only if you are only working within one dimension. But here is something that is not okay. What if you took 2 seconds of time and tried to add it to 5 kilograms of material? nobody will know what you're talking about, right? Because this plus doesn't mean anything, right? There is no physical result that looks like 2 seconds plus 5 kilograms. You cannot add and subtract in different dimensions. But it is always okay, although not necessarily meaningful all the time, but it's always okay to multiply and divide different dimensions. For example, this is how you can get composite pieces of data. So for example, speed. Speed is a distance per time, right? So this per is the same word as division. It's distance divided by time. And units that would be appropriate to talk about speeds are meters per second, as well as miles per hour or kilometers per minute, right? Sort of any distance unit divided by any time unit. Not only can you multiply and divide different dimensions, you can also multiply the same dimension. So, for example, something like area. You know that area of a rectangle. So here's a rectangle, and it's got a width and a length, and the area is equal to the length times the width. If the width is in meters and the length is in meters, then the area is going to be in units of meters squared, right? So it's always okay to multiply and divide same units or different units. But you have to be really careful. It's not okay to add or subtract different dimensions. All right, that's it for this little introductory video about units and dimensions and math.